In 1743, observers claimed to have seen a comet with 6 tails. Little did they know that the streaks behind the comet could be related to the origins of the solar system. In time, scientists theorized that the dust in a comet's tail had been combed out into bands known as striae. How the striae formed, however, was still a mystery. How dust behaves in a comet's tail is exciting because comets are the leftover building blocks of the solar system. By watching the material clump and fragment in the tail, we can gain insights into the same process that forms dust into planets, moons, or asteroids. In 2007, researchers were able to capture images of Comet McNaught with NASA and ESA's SOHO and Stereo spacecraft. Today, researchers are introducing the latest step in analyzing footage like this, a new image mapping technique. When the technique is applied, it seamlessly combines perspectives from multiple spacecraft, giving us a clearer picture of how the dust trail changes over time. In the processed footage, we see the new striae form. Their alignment relative to the Sun indicates that the star might play a role in striae formation, as well as fragmentation. We can also see how the clean lines are disrupted when the comet crosses the current sheet, the boundary where the solar wind's magnetic field changes orientation. Notice how the defined lines become broken. This tells us that the dust is charged, and the characteristic lines of the magnetic field in the solar system are affecting it. Scientists can use the new processing tool to study dust behavior in other comets. When it comes to learning how comets can teach us about our origins, we've only just caught this by the tail.